In this short video, we're going to look at the CFD modelling of a ball check valve. We will explore the use of Cradle CFD in modelling valve behaviour to improve both the design and the operation of valves. Valves are used in a range of processing industries such as food and beverage, water and wastewater, chemical, and of course oil and gas. They're used mainly for regulation, direction and control of liquids, slurries, gases and vapours. Valves come in a wide variety such as globe valves, butterfly valves, ball valves, gate valves, plug valves, pinch valves and of course check valves, but to name a few. And while the cost of a given valve is not that significant typically, the impact of failure can be devastating, as we can see on this slide. Using Cradle CFD, we can effectively model the behaviour of any valve, whether to aid in its design, evaluate behaviour and operation, or provide insight into the physics of failure. Before we look at the ball check valve model, let us remind ourselves of the role and function of a check valve. Well, check valves are designed to prevent the reversal of flow in a piping system, and they are quite simply activated by the flowing material in the pipeline. The pressure of the fluid passing through the system opens the valve, while the reversal of flow closes the valve. The great advantage of check valves is, of course, they are fast acting, they are self-actuated, it allows flow in only one direction, and it has a relatively low pressure drop associated with it. The disadvantages are that all moving parts are enclosed, so it's difficult to ascertain whether the valve is open or closed, and the condition of parts cannot be directly assessed. Each type of check valve has its own limitations, and valve discs have been known to stick in the open position. In this video, the ball check valve, or the ball in the ball check valve, is represented with an overset mesh and with 6 degrees of freedom motion. This means that the movement of the ball in the valve here is given by the force and moment balance acting on it. In case of rigid motion, Cradle is able to handle this alone without any co-simulation, and it can take into account a spring force, a resistive torque and so on. The ability to handle the valve ball seat contact is important here because it enables the ability to simulate the stages of opening and closure. During these stages, we sometimes observe a vibration of the ball, which can cause some mass flow or pressure fluctuation at the exit, which most of the time are completely unwanted. If you're interested in what you've seen in this short video today and want to talk more about this, or more broadly about the technologies underpinning the digital revolution in your company, please feel free to reach out to us at Cygnas. Thank you very much.